Okay, this lesson is going to be on things sliding down inclined planes. So if I take a look at this picture, I know that 2 kilogram mass is going to slide down the hill, and I want to find out what the acceleration of the block is going to be. Now, let's start identifying forces on this. The first force is going to be gravity. Gravity always points straight down towards the center of the Earth. So we're going to draw our arrow straight down. We're going to label it Fg. We know the size of it is going to be 2 kilograms times 10 gives me 20 newtons. Okay? Now, the normal force is going to look a little funny in this one because if you remember, normal means perpendicular to the surface. So it's not going to be pointing straight up this time. It's going to be pointing off this way at a right angle to the surface. Okay? Now, the trick to these problems is I know it's going to go in this direction. So I'm going to call this my x direction, and y is always perpendicular to x. So I'm going to call that my y direction. So now I have to look at my forces. Fn, y is perpendicular to the plane, Fn is a y force. Okay? Fg is not perpendicular to the plane, and it's not parallel to the plane. Okay? It's a little bit of both. So we're going to have to find the component of it that is perpendicular to the plane and the component that's parallel to the plane. So the trick is I take this 30-degree angle, and whatever angle I have down here goes up here, right here. And I'm going to draw in the components. Okay, this is FGY, the component that's perpendicular to the plane, and this is FGX, the component that's parallel to the plane. Don't draw this part. I want you to see what this is looking like. This is really maybe a rectangle like this. Okay, FGY is here, FGX is here. I get a right angle down here. And since I have a right angle here between x and y, I can use sine and cosine to find these. Okay, so going back to our picture. Now, for y, we have to be careful. When we've been doing problems before, y was usually sine, but for this one, since my 30-degree angle is right here, y is the one that's adjacent to it. So FGY is now the adjacent one. For adjacent, we use cosine. So it's going to be 20 cosine of the angle, which was 30. When we do that, we get a value of 17.3. And for the x, then, it's going to be the sine, because it's really like this side of this triangle that I've moved up over here. So it's going to be FGX is 20 sine 30, and that's going to give me a value of 10. And I like to write these right on here. So I know this is 10 going down the hill, and this FGY is 17.3. We're not going to need it for this particular problem, but since it's not moving in the y direction, it's not going into or out of the plane, it's only moving in the x direction this way, I know that the Fn and the FGY have to cancel. So Fn is going to be 17.3. It's not equal to the force of gravity in this case because they're not directly opposing each other. Now, we're almost done with this problem. We need to find the acceleration of the block. So we're going to do Fnet equals ma. It's moving in the x direction, so we're only going to use x forces. And in this case, the only x force is this FGX. So FGX is going to equal our ma. So FGX was 10, our mass was 2, and the acceleration's a. And when I solve that, I'm going to get a is 5 meters per second squared. Now that makes some sense because if it was falling straight down, the acceleration would be 10, and this is lower than that, so it makes sense. Now, at the top of the next page is a really gory, awful problem. So if you get confused as I'm going through this, it's okay. The more we practice it, probably the better we'll get. This has an angle in it, it's got friction in it, it has no numbers in it, so this is an intimidating problem as I can give you. If you can fight your way through this, this is as hard as they can get. So, we're going to start with some free body diagrams. Let's start with M2, because that's going to be the easy one. So I'm going to draw my block for M2. And what force do I have on it? I have gravity down. So FG is going to be M2G. And then I have a string up, so I have a tension up this way. I haven't said which way it's going to go. So let's say this. Let's say that M2 is going to be greater than M1, so it's heavier. So I know M2 is going to go down because it's the heavier block. The reason I need to know that is when I do FNet equation, I need to know which way it's going to move. So since this one is going to move down, I'm going to do M2G minus T equals M2A. So there is my equation for that block. Now for the fun one. All right, for this thing, we got to start drawing and labeling forces in it. We know we have gravity down, so we have Fg going down this way is M1G. Right. We have a normal force going off this way, Fn. We have a tension from the string going this way, which is T, and we have friction. Now, in this case, since it's going to be moving up the hill this way, friction has to be back this way. So we'll label it FF. If it was going down the hill, FF would be the other way, the same direction as the T. Now, remember, this is our X direction. You don't have to draw this every time. I'm just doing it to remind us what's going on. So T is an X force, FF is an X force, Fn is a Y force, but we got to split up this Fg. So we split it up into FGY. It's easy to remember. If you remember that the Y is always opposite the Fn, it might help. So here is FGY, and then this one going down this way is FGX, and my angle theta goes up here. Now, since that Y is the adjacent to that, I'm going to use cosine. So over here, I'll make a note that FGY is going to be FG cosine theta. Nice. Okay, so that's going to be M1G cos theta. And I can't neaten it up any. That's the best I can do with it. FGX is going to be this mg, but now it's going to be sine theta. So m1g sine theta. All right, now this ff we can do a little bit with. We know that ff is mu fn. Remember, fn is going to be the same as fgy. So we can make note of that. This equals fgy equals m1g cos theta. So now over here I get ff equals mu m1g cos theta, because it's the mu times the fn. Now I've done everything I can. I have to do a free body, I have to do an FNet equation. So we'll do FNet equals MA. It's moving the X direction, so we just want to look at the X forces. There's actually three of them this time. There's T as an X force, there's FF, and there's FGX. So it's moving up the hill, so the T is going to be positive. It's going to be T minus FF minus FGX equals MA. So now I can start plugging in what I have for these. It's going to be T minus FF is up there is mu M1G cosine theta minus FGX is M1G sine theta equals M1A. And we'll put a big box around that guy. Okay, now how do we solve it? We combine the two equations. So we have M2G minus T from the first equation we had, and I'm going to add the second equation, T1 plus mu M1G cos theta minus M1G sine theta. Then I'm going to add the right sides, M2A plus M1A. Now, the T's cancel, so I know I'm on the right track. And I get M2G, oops, I missed a sign here. This one should be minus. Minus mu M1G cos theta minus m1g sine theta equals m2 plus m1. I'm going to factor an a out of this side. When I'm solving for a, I would just divide by the m2 plus m1. So my final answer is m2g minus mu m1g cos theta minus m1g sine theta. I'm going to divide that by m2 plus m1, and that's equal to the acceleration. So that mass is the answer. Okay, and I kind of like problems like that because it's neat that that big mass can be the right answer.